Welcome to The Explainer. Today, we're decoding a piece of everyday magic, something pretty much every gardener and plant lover has witnessed firsthand, but honestly, very few truly understand. We're breaking down the absolutely fascinating, highly specific science behind rainwater's unbelievable effect on plants. Okay, let's dive right into this. Just think about your own garden for a second, or even the trees in your neighborhood. You can stand there and water them with a hose for weeks on end, but the morning after a heavy thunderstorm, boom, there is this sudden, undeniable burst of vibrant green. The plants literally look taller, the leaves are glossier, and the overall vigor of the whole plant seems to have just multiplied overnight. It's a completely universal experience, right? But what exactly triggers that massive explosion of life? Well, it's definitely not magic. It is the result of a perfectly synchronized cascade of chemistry, physics, and biology. To truly understand why rainwater accelerates plant growth so drastically, especially compared to standard tap or well water, we really need to look at the process chronologically. So we're going to track the wild journey of a single raindrop. We'll follow it from its chaotic creation, way up high in the stormy clouds, all the way down through the plant canopy, and finally deep down into the soil matrix. Section 1. The atmospheric spark, lightning's natural fertilizer. So our journey begins way up high in the atmosphere, right smack in the middle of a chaotic thunderstorm. Before a drop of water even touches a leaf, this violent weather actually physically alters the atmospheric chemistry in a way that directly benefits our soil. Now, what's really interesting here is that while the air around us is made up of 78% nitrogen, plants are basically completely surrounded by an ocean of fertilizer that they just can't drink. That atmospheric nitrogen is diatomic. That means two nitrogen atoms are locked tightly together by a remarkably strong triple covalent bond. It's totally inert to plants. For a plant to actually use it to build proteins and grow, that stubborn bond has got to be shattered. And, as it turns out, that is exactly what a thunderstorm does. When lightning strikes, it generates extreme thermal energy, literally heating the air to 5 times the temperature of the surface of the sun. No kidding. This immense power easily severs those tough nitrogen bonds. Then, those newly freed nitrogen atoms immediately combine with oxygen in the air to form nitrogen dioxide. As this gas mixes with the water droplets up in the storm clouds, it creates a dilute nitric acid. So, what ultimately falls from the sky is actually a highly bioavailable liquid fertilizer in the form of nitrates. To really grasp the awe-inspiring scale of this natural electrical process, just think about this. Globally, lightning generates over 10,000 tons of nitrates every single day. That's a staggering amount of fertilizer. Every thunderstorm is essentially this massive, totally free fertilizer application falling right out of the sky, delivering essential nutrients straight to the root zone without the plant needing to expend an ounce of energy on complex biological nitrogen fixation. Section 2. The free fall, the power of oxygen. Let's move along and see how this builds. As our raindrop, which is now completely loaded with nitrates, by the way, plummets through the atmosphere, another absolutely crucial physical process takes place as it cools down. During this free fall, the water becomes supersaturated with something called dissolved oxygen, or DO. Now, it's really important to differentiate this molecular oxygen, which is kind of just suspended between the water molecules, from the oxygen atom that's actually bonded within the H2O molecule itself. Cold, pure rainwater naturally holds massive, massive amounts of this vital dissolved oxygen compared to just standard stagnant tap water. And that's simply because colder, purer water physically has a much higher carrying capacity for holding gases. And this dissolved oxygen, it acts like a high-performance engine for the roots. Plant roots desperately require oxygen to carry out aerobic respiration. That's the process of turning glucose from the leaves into ATP energy. So with all that high dissolved oxygen from the rain, roots can produce way more ATP, which allows them to absolutely gorge on water and nutrients. Think of it like giving a race car engine a shot of nitrous. This expands the root mass incredibly rapidly. Plus, a highly oxygenated root zone is incredibly hostile to devastating anaerobic pathogens like Pythium, so it's actively helping the plant fight off disease at the same time. But hey, oxygen isn't the only gas hitching a ride down to Earth. As the drop falls, it's also absorbing atmospheric carbon dioxide. This forms a weak but highly beneficial carbonic acid. By the time that raindrop actually reaches the ground, its pH naturally drops to a mildly acidic level of about 5.5. And as any experienced grower knows, a slightly acidic environment is absolutely the perfect chemical baseline for maximizing nutrient uptake in plant life. Section 3. The canopy impact. Perfect physical delivery. Now, let's shift our focus spatially to the exact moment the rain finally hits the leaves of the plant. The physical conditions of a rainstorm completely optimize how a plant drinks. Think about it. During a rainstorm, the ambient relative humidity approaches 100%. This means there's basically zero evaporation happening. Contrast this with artificial watering from a hose, which we often do in lower humidity or even active sunlight. When artificial water evaporates rapidly off a leaf, it leaves behind this damaging mineral scale that physically clogs the stomata, the tiny pores the plant actually uses to breathe. Rainwater falling in that zero evaporation environment leaves absolutely no residue. Instead, it coats the entire canopy, allowing the leaves to effortlessly drink in those dissolved atmospheric micronutrients directly through foliar absorption. It's perfectly efficient.
Section 4. Perfecting soil chemistry. The root and soil flush.
So the crucial point is, after perfectly coating that canopy, the water drips off the green leaves and begins to infiltrate deep down into the soil matrix. And this is where rainwater performs some of its most impressive chemical heavy lifting. Rainwater possesses near-zero alkalinity, which means it doesn't artificially raise the pH of your soil the way hard well water does. Instead, that weak carbonic acid we talked about earlier, it goes straight to work as a gentle solvent. It actively dissolves locked, totally insoluble base cations in the soil, things like calcium, magnesium, and potassium, and makes them immediately available for the roots to take up. Plus, the slow, steady duration of a natural rainstorm ensures really deep, uniform penetration, which encourages roots to dive deeper and build a much, much stronger structural anchorage.
Section 5. Why tap water fails. The drawbacks of artificial irrigation.
To fully appreciate the superiority of this whole natural process, we really have to pivot and look at a direct comparison. We need to examine the hidden drawbacks of relying on municipal tap water or well water for our gardens and crops. Think of tap water kind of like a bad fast food diet for your plants. Sure, yes, it hydrates them, but it leaves behind heavy, hard mineral loads that the plant frankly doesn't want. Because rainwater has virtually zero dissolved minerals, it has what we call an extremely high water potential. In biological terms, this means it requires absolutely zero metabolic energy for the plant to absorb it. Tap water, on the other hand, is laden with salts and minerals, which actually forces the plant to spend precious energy just trying to filter and pull that heavy water into its cellular structure. And then, of course, there are the intentional additives. Municipal tap water contains sanitizers like chlorine and chloramine. Now, these are obviously great for human safety, but they absolutely decimate the beneficial microbial life in your soil. Furthermore, tap water, especially if it's being run through a sodium-based water softener, presents a massive sodicity hazard. Excess sodium totally destroys soil structure. It causes those fine clay particles to disperse, clump together, and form these hard crusts that literally suffocate roots and block drainage. It's a real problem.
And this brilliantly illustrates exactly why rain is so wildly restorative. Because rainwater is so exceptionally pure and has such a low electrical conductivity, it basically acts as a giant natural reset button. It serves as the ultimate flushing solvent. It sweeps through the soil profile, dissolving and leaching away all that toxic salt and mineral buildup that gets left behind by months of municipal tap water irrigation. It literally washes the soil clean.
From the violent shattering of nitrogen bonds by lightning, down to the oxygen-rich freefall, and finally the gentle acid wash of the soil profile, a rainstorm is basically a highly orchestrated delivery system of life. So it leaves us with a pretty compelling thought. If this incredible, free atmospheric miracle is literally falling from the sky, how much more growth, yield, and vitality is just waiting to be unlocked in our own backyards if we actually start harvesting the chemistry, physics, and biology of every single storm? It definitely makes you look at the next rainy day in a completely different light, doesn't it?